a whole bunch of you are installing your antennas incorrectly. And I'm going to tell you why and the right way to do it. This is the antenna from a FreeSky receiver, and it may not be obvious if you don't already know, but this is not just a length of wire, right? This is actually coaxial cable. It is very, 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 very small, very fine coaxial cable. So I've got a bigger coaxial cable. This is the same kind of coax that you've got bringing your cable TV into your house, and it's much bigger and easier to understand. So the structure of a coaxial cable is, on the outside we've got this protective sheath that provides physical protection against damage. And then the next thing we've got is a metal layer whose purpose is to shield or ground the wire and prevent outside signals from getting in and putting noise on your wire. And if you've got this wire putting out noise, it'll prevent the wire from inducing noise onto other nearby electronics. So it shields the wire. And the way it does that is that this metal sheathing here is grounded. It's connected to the outside barrel of the connector, basically, and that is grounded. And that essentially creates a Faraday cage, if you will, out of the wire. Okay? So we've got this sheathing here, which I've folded back. And then the next piece is we've got a thing called the dielectric, which is this white stuff here. I hope you'll pardon my focus. The dielectric helps tune the impedance of the wire. It's very, very, very important the dielectric have the exact right impedance. It makes the wire have the right impedance that tunes the wire properly for the kind of RF system you're using. The wires we use have 50 ohm impedance. This, for your cable television, I believe is actually 75 ohm. And that's one of the reasons why you can't just take some cable TV coax and use it in your RF microwave system. They don't have the right impedance and it won't work right. So then, if I take and I cut back the again, I apologize for the focus, but there's only so much I can do here. If I cut that back, here is the inner conductor. This is what carries the actual signal. Actually, technically this is an AC system, so the ground sheath also carries the signal, but we don't really think of it that way. Anyway, let that go. Now, if you are going to make an RF antenna, one of the simplest ways to make an RF antenna is to just have a piece of wire. And the piece of wire needs to be the right length, because the way RF systems work is that the length of the radiating element determines the wavelength to which the antenna is tuned. And there's more to it than that. The antenna is not tuned just at one wavelength. It is maximally sensitive at one wavelength, and then the sensitivity drops off as you get to further and further away wavelengths, and that's a whole topic all of itself. But basically, the length of this is very, very important. So the simplest thing to do is to take the wavelength of the signal that you're trying to receive and make this as long as the wavelength. But that tends to be a little bit long, so you can also make it a half a wavelength or a quarter wavelength. The point is, though, that if this wire is tuned to a certain frequency, and then we go like that, we've now changed the length of this, right? And therefore, we've changed the frequency at which this is now maximally sensitive. We've changed the tuning, so that's no good, okay? The other thing is that this needs to be straight. If we have this at the right length, and we go and we just make it look like this, well, it's still kind of straight. That's not the worst in the world. Oh, now I've broken it. If we bend it up, basically, it needs to be straight, okay? So it's less sensitive if it's not straight. Okay, push that aside. Let's go back to this. What I see a lot of you guys do is you got these whisker antennas, and you've got some nice little, some kind of drinking straw or coffee stirrer or whatever, and it comes right up to here, and then sticking out the end of it, you've got this thing, and it's been hit by your antennas and crashed into a tree branch, and it's just like this, and it looks like that. This is the most important part. This is the antenna. This doesn't matter. This is just a wire carrying the signal to the antenna. This is not radiating. This has nothing to do with the transmission of signals into the air, except in as much as it carries the signals from point A to point B. This is the most important part. This is the part you should be protecting. This part too, because without this part, then this part doesn't do anything. But if you've got a copter and you've got some kind of a support for your antenna, like a zip tie or a coffee stir or whatever, make it long enough that it protects this part too, because that's the most important part. You don't want this just dangling out of the end, bent over like that. See, that's bad. A sharp bend like that, that's bad. That's hurting your range. And if it's kinked like this, that's bad. It needs to be straight. And it's getting cut or clipped or whatever. No. Make your antenna support, your antenna protection long enough that it keeps this straight and it protects that part. Okay? So if your antenna is all screwed up like that, like I've just done here, you can actually, I'm never going to be able to do this, but you can actually cut it off and you can just strip back again the insulation and the metal sheath. I'm not going to show you how to do that because I would just screw it up. And Bruce at RC Model Reviews, who I'm sure you all watch and subscribe to, he has a video on how to do that as well. But yeah, don't leave this part sticking out of your antenna support. That's the most important part. And now you know. Hope it was helpful. Happy flying.